All right, here we go. Proving trig identities paper in class questions 7, 8, and 9. Last three. If you're here, you're doing great. So glad that you're using these. Hopefully they're helping you. So question number 7 says 1 plus secant squared of x times sine squared of x is supposed to equal just secant squared of x. So I'm going to start on this side. There's more things happening. Let's change the secant. Secant is 1 over cosine. It's the same thing as that. So change that 1 plus 1 over cosine squared of x, and then we still have this times sine squared of x. So I'm just going to focus on this left side. So right here, sine squared over cosine squared, that is worth tangent squared. If it was positive, sine over cosine, that would just be regular tangent, not squared. So these both have to be squared in order for it to be tangent squared. Okay, that looks something that looks familiar. So from our toolkit here, this one, 1 plus tangent squared of x equals secant squared of x. So I'm going to replace that, and this whole stuff turns into secant squared. And maybe that looks like a dividing line. That just turned into secant squared. And that is, in fact, what we wanted to get. So that one was hopefully not too bad. Okay, problem number 8, we have tangent squared of x equals, sorry, I didn't mean to bump that. Equals secant squared of x minus sine squared of x minus cosine squared of x. So we got a lot going on in this one. So I'm going to start off on the right side this time because there's more stuff happening. Might be easier to deal with. Something that we can do, if this was sine squared plus cosine squared, that would be worth a 1. So what I could do here is take away or pull out these negative 1s. So I'm going to leave this as secant squared for right now, and then we can maybe change it if we need to. But I'm going to pull out these, I'm going to factor out these negative 1s just from this section right here. They have this in common. So negative 1, this would just be regular sine squared, and then this turns into a positive cosine squared of x. Okay, so now this part in here, that's one of our identities, and that's worth a 1. So really, we don't even need that part anymore. We just have secant squared of x minus 1. Before we change this into 1 over cosine squared, we're trying to get tangent squared. So if we look at our handy dandy toolkit here, maybe you're liking this because it's like geometry of toolkits all the time. So if I take this one, let's see, what were we trying to get? I forget already. Secant squared of x minus 1. If I subtract 1 from each side of this, minus 1, I get secant squared of x minus 1 equals tangent squared. So we're going to change that out to be tangent squared. And that's what we wanted. So that one's all good. All right, hopefully you can see that all. I'm moving it around too much. Okay. And then finally, number 9. We've got this crazy stuff here. We're going to start on this side because there's a lot going on. We have 2 fractions with that plus sign in the middle. These need to be the same denominator. Unfortunately, they are not. One's a plus and one is a minus. So let's multiply this second fraction by 1 minus cosine of x on the top and the bottom. 1 minus cosine of x. Okay, we're not doing anything with this right side. It's just kind of in the way right now. So then the other one I'm going to multiply by 1 plus cosine of x. On the top and bottom, we need to multiply by that giant 1. Okay, so top and bottoms are going to be multiplied. So we're going to have a lot of stuff happening in the denominator, but we'll just keep it, we'll simplify it, it'll be fine. So basically I'm distributing the sign to both things here. So I'll get a sine of x, then I get plus sine cosine. They're just multiplied together. Okay, now I'm going to do the top of the other fraction, and then we can look at the bottom together. So distributing sine to the 1 and sine to here, so we have a plus sign between the fractions. So 1 times sine is sine, and then sine times the minus cosine is minus sine of x, cosine of x. Whatever order you want is fine. Cosine first or the sine first, doesn't matter. So then the bottom, if I really multiply 1 times 1, I get a 1. 1 times negative cosine, we get negative cosine. I guess I should actually write that a little darker so you can see it. Sorry. And then if I did this times this, this times that. Now cosine times both things, so I get a positive cosine of x, and I get a negative cosine squared of x. That's what the whole denominator kind of multiplies out to be. And remember, if we add fractions together, we're going to keep the bottom the same. We're not going to do anything and add another one of these to it. It's just this will be the bottom. But our cosine of x and our minus cosine of x can cancel out, so we really have 1 minus cosine squared of x is our entire denominator. So let's see, we can kind of cancel some things out. We got a sine and a cosine multiplied, and we got a negative sine and cosine multiplied. So let's get rid of those. That would result in 0. In the top we have a sine plus a sine, so that's 2 sine of x over 1 minus cosine squared of x. Okay, so from there, 1 minus cosine squared, maybe you're just kind of getting more acquainted with these identities, but that is an identity we rearranged to prove. So we're trying to get 1 minus cosine squared. Well, we have that, I wrote it right here. If we take this original one and subtract cosine squared from both sides, we get sine squared is worth 1 minus cosine squared. So this bottom is just going to turn into, let me just move it maybe this way instead. This bottom just turns into sine squared of x. Okay, get this out of the way. So from there, we have a sine over sine squared. That can reduce to just a 2 on the top and then a sine on the bottom. And from there, 1 over sine, if you need to think of it as 2 times 1 over sine of x, 1 over sine of x is worth cosecant. And that's actually, that's what we wanted. If we go back up to the top right here, 2 cosecant of x, we proved that it is worth the same thing. Okay, so make sure to write this all down and come prepared for questions on Monday.